So this is module 4, and we're going to talk about applications for digital LMR, and there are many out there. This is some of the main ones, but there's new ones being created all the time. These are the ones we're going to talk about. Some applications that you're probably familiar with, some you may not be. Mobile data, which almost everyone's familiar with. Status message capability. SMS text messaging. GPS and vehicle tracking. Radio check, alert, radio inhibit, encryption, over-the-air rekeying, over-the-air reprogramming, and radio authentication. So mobile data is a very generic term for all the different third-party applications that are out there that can leverage the radio infrastructure. So you may hear about a lot of different data applications out there in different industries. For public safety has their mobile data applications, and transit and taxis and buses have their applications, and every industry has something. So mobile data is the ability to support those applications over radio, or digital land mobile radio. So what you need to do to support that is enhance your infrastructure with the servers that will allow you to optimize the throughput. You can't just hook computers to the radio and off you go. There has to be a way to process the data packets differently than you process the voice packets. Because most land mobile radio systems are primarily operated as voice systems, you need to prioritize voice packets over data packets. In a typical first responder public safety radio network, the primary application is voice and data is secondary. There are other systems where data is the only application, but we're going to talk about those where it's secondary. And to make it secondary, you have to handle its packets different. Things like QoS have to be handled differently on voice data packets, so they'll be processed differently. So you've got data servers. The actual user device, in the past, there were all kinds of dedicated data terminals, and there still are a lot of dedicated data out there. But today, it's primarily either mobile laptops or tablets or handheld smartphones. These are the more common user terminals, which do double duty as tablets or phones or PCs. This way you take advantage of the IP-based protocols, where previously in the early generations of mobile data, there were proprietary protocols. Today, we encapsulate IP protocols with RF data protocols and make it work. So that's what we do. Today, everything's based on either layer 2 Ethernet or layer 3 TCP IP technology. Take the packet, optimize it for use over the air transmission. Now, you're not going to get the same kind of data rates that you get on your Wi-Fi or your Ethernet landline, but you will get the same capabilities because you're still dealing with IP packets. So P25 provides the data services protocols and interfaces to support these. That's part of the P25 standard. And this allows us to use the industry standard servers, routers, switches, and other devices that are normal in any data network today. So we'll use these to encapsulate the IP data packets into P25 and other packet structures. We'll show some of the infrastructure it takes to do that. So here is a typical mobile data infrastructure. These are stacks of virtual servers. Today, virtual servers are what's being used to perform a lot of different functions. And some of the virtual server applications have to do with processing packet data. and we call those packet data gateways. We also have data encryption modules in there if the data needs to be encrypted. We also have special types of routers that only handle data, that optimize and prioritize voice packets and data packets. So we need servers, routers, switches, just for the data side of things. A P25 packet, we said it was, the raw data rate was 9,600 bits per second. Well, that 9,600 has two parts to it. There is 2,400 of that is embedded signaling. This has to do with RF signaling and error detection and correction. 7,200 of that 9,600 is allocated for the P25 voice and data packets. So 7,200 bits per second is available for the data side. Within that 7,200, we have the P25 overhead, and then we have to encapsulate IP data packets. So with all this encapsulation going on, that's why we can't get the types of data rates we would see on something like Wi-Fi, where we have huge bandwidth. We have to do everything within our 9,600 bit per second bandwidth. Some of the data terminals out there today, this is on the upper left, is like a Panasonic Toughbook, which is used a lot by first responders. Then we have tablet PCs and smartphone applications that can be used. So one of the first and earliest applications of mobile data was a service called status message services. And the picture shows a type of control head used on the radio that supports status message. And what this is are predefined or pre-programmed messages that are programmed into the radio that take care of routine type messages, so you save airtime. If your job is to do service calls all day, then most of your radio traffic consists of I'm in service, I'm out of service, I'm heading to the office, I'm going home, my job is complete, those kind of routine messages. So why should you take up all the airtime with what amounts to routine messages? So that's why we have the status messages. These are soft keys on the control head that allow you to send these quick messages to dispatch. So it's called status message because status means the incoming message you send to dispatch, and message are the messages, the pre-programmed messages, like acknowledgement messages that are received from dispatch. So some of the examples of this would be I'm in service, I'm out of service, I've arrived at the scene, my job is complete, those kind of things. So that's been around. That even existed in the analog world, but it's been carried over to digital. SMS. Everybody's into text messaging these days. Well, P25 and DMR can support short message service as a type of mobile data service. You can, just like on your phone, you can store the numbers of the people you commonly text. You can put a name associated with it, and then you can pull up the name, write them a short text message, and send it out just like you would on a smartphone. So that was a fairly easy application. You got the data infrastructure. Why not support text messaging? Let's see. Okay. So the next thing is GPS and vehicle tracking. So originally, when vehicle tracking came along, came way before GPS. They had different means to track vehicles using fixed signposts and using Loran signals or other type of signals that were out there. But when GPS came along, that pretty much took over as the main way that we locate people. So the automatic vehicle location is an application that allows subscribers equipped with GPS receivers to get their locations, track them on a map, and provide fleet management over a wide area. The dispatchers want to know where is everyone, what was their last known location, and this is all done without any user intervention. It can be set up to either send a location every time he transmits, or it can do a fixed interval, or it can poll the system on demand where the dispatcher sends a request and everyone sends back their location. There's a lot of different ways you can do it, but what they all have in common is the GPS is embedded in the user radio. It's tracking the location, and on demand or on period, it sends that location back to the dispatcher, which is then tracked on a third-party application to provide a map display. You look at most of the mobiles and portables that are out today in land mobile radio, you either have built in or the option to have a GPS receiver built in. And of course, there's a separate GPS antenna for a mobile. In the portables, the GPS antenna is embedded within the regular antenna. So you need a server and a third-party application to make it work. And there's a simple diagram. GPS satellites go to the vehicles report over the data network, it goes to a processing server, and then to the dispatch center. Since it's third party, you basically have a application programming interface that lets it talk to the radio system. There's another function called radio check, which is a nice one because it's a simple feature that checks the availability of a specific radio unit. If you want to know, is somebody still out there, and you called him but he doesn't answer, he's still out there, you can basically ping him with the radio check feature, and whether he's listening or not, his radio will respond to your radio check ping command and let you know if he's in service or not. Another feature is called private call or call alert. They're slightly different. Private call is a P25 service originally specified by APCO 16, but now incorporated the P25. Allows one user to call another user individually, so it's a one-for-one call. A lot of systems don't like to use it because it uses a lot of resources just for two people in a conversation, but it is available. On the other hand, call alert is more of a alerting system or a paging system that will send an alert tone to an operator. So if he's away from his radio or away from his vehicle, it'll alert him that somebody's trying to reach him. And so the call alert is made by one radio to another, private call or call alert. The radio displays the ID of the caller, allows them to call back. Radio inhibit is a neat feature. A lot of system operators like this because they have a problem with radios getting lost or stolen. And that could compromise the entire system, especially if it's a secure type system. So radio inhibit is a feature that allows the system administrator to send a signal out to a lost radio that will basically disable it, turn it into a brick so it can't be used to send or receive calls. And then if the radio is later found or recovered, you can then send an uninhibited signal that will bring it back to life. Encryption. So we talked about voice encryption, how P25 specifies AES for voice encryption. We can also encrypt our data, especially sensitive data. We don't want people to intercept it. So there is an option in P25 for AES encryption for data as well as voice. And this is an end-to-end encryption where we have encryption devices at each end that will encrypt the data going out. So you may need some additional hardware or software encryption modules. Increasingly, encryption is becoming a software product rather than a hardware product. You can manage your encryption keys with a infrastructure server system called a key management facility. And again, all this is optional if you choose to encrypt your data. So if you do encrypt your data and you have a fleet of users out there, the biggest challenge you'll have is if you have to rekey a radio. In the past, you had to bring it back, plug a key-loaded device into it, and then send it back out. But with over-the-air rekeying, that's another P25 feature, you can send the air to the subscriber units, and the key itself is encrypted when it's done. So P25 provides for that. So you don't have to have your manual key loader and bring in every device every time somebody loses a key, or you have to change the system key. This uses that key management facility server as well as the data infrastructure itself. And there's a variation on over-the-air rekeying that because you have dispatch consoles that employ end-to-end encryption, the consoles have an encryption module in them as well. So rather than using your key loader to load the key into the dispatch consoles, since they're connected by Ethernet to the system infrastructure, you can send the key over the Ethernet to the consoles and it will load a new key into the encryption module. And that's called over the Ethernet keying, or OTEC. You may hear the terms OTAR or OTEC, and this is what they're talking about. Over-the-air programming sounds similar, but the over-the-air programming is how you load a new configuration file, or what's known as a code plug, over the radios. So since the radios today are all software programmable, and since changes are constant, if you want to load configuration changes, you don't have to pull all the radios back and manually load those changes with a cable. You can do that over the air. And those configuration files that get sent over the air, you're not sending the whole file, you're just sending what changed from the last version. So you have a server and a database that tracks all those configuration files, and then whenever a change is made, it manages how and where to send those out. So the first generation did it over the P25 network itself, but now they also have provisions to program over Bluetooth or Wi-Fi networks. So for instance, when the officer comes back to the station, there's a Wi-Fi access point, he can get a new configuration file loaded without him even knowing it's happening. So again, you have to have the database management of all those subscribers and code plug files and the data infrastructure to make it work. And the final data application I'm going to talk about is something called radio authentication. Now you may have run across cases where unauthorized users got a hold of a radio and were able to program it with the IDs of a system so that it would be recognized by a system, and they call that a cloned radio. That's been an issue that system managers have had to wrestle with, these illegal users coming on because somebody got a hold of, basically a hacker got a hold of it, created the right IDs to let it be recognized by the system. And so it would spoof the system into thinking it was a valid user. What radio authentication does is, just like an encryption key, there is an authentication key that gets loaded into the legal users. And whenever that radio turns on, there's a handshake that goes on where you exchange information over the control channel. Again, this is a very quick operation that the user's not even aware of. And that authentication key in the radio is checked against the authentication database server. And if you don't have a valid authentication key, it will then not let you in the system. So anybody who just picks up a used radio over eBay and decides to program it is not going to be able to get in the system.